Hey everyone, in this video we're talking about evaluating trig functions. For an acute angle in standard position, we have the following image where our angle would be here. Standard position, we have our vertex at the origin, 0, 0. Our initial side of our angle or triangle is on the positive x-axis, and then our terminal side is swept through this angle theta. And then based on this angle, we call the side away from it the opposite side. We call the side that touches the angle the adjacent side, and then the terminal side of the angle, or the long side, is called the hypotenuse. And then we use these three sides to talk about our 6 trig functions. So we have our right angle, our right triangle definitions of our trig functions. And so we have sine is opposite over hypotenuse, and so SOHCAHTOA helps you remember that. So sine is the opposite side over the hypotenuse. Cosine is adjacent side over hypotenuse, so SOHCAHTOA, adjacent over hypotenuse for cosine. And then tangent, TOA, is opposite over adjacent, so the opposite over the adjacent side of the triangle. So SOHCAHTOA helps you remember that. And then the other three are just the reciprocals of these. So as long as you know sine, cosine, and tangent, you can figure out cosecant. It's the reciprocal of sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So let's take a look at this example. Find the values of sine, cosine, and tangent of angle A in this right triangle. So notice angle A is this one here. And so based on this angle, we want to consider, okay, this is our angle with our triangle, so that means that the side touching that angle, that's the adjacent side. So this is the adjacent side, and then the side opposite this angle, way over here, that's the opposite side. Okay, so 24 is our adjacent side based on where angle A is located, and then the 7 is the opposite side. And then the longest side is always the hypotenuse. So this is the hypotenuse. And so we use that information to find all of the trig function values. And so sine is opposite over hypotenuse. And so 7 over the 25. Cosine is adjacent over hypotenuse, so 24 over 25. And then tangent is opposite over adjacent, so 7 over 24. And those are our main trig function values, and if you wanted cosecant, secant, and cotangent, you would just flip over these values. So there are some angles in trig that we use quite often, and they are 30 degrees, 45 degrees, and 60 degrees. And so we can use triangles to figure out these trig function values. And we can get these side lengths in order to plug into our trig functions, basically from the fact that we have this equilateral triangle with all the angles at 60 degrees. And if we just call each of those side lengths 2, because it would all be the same size, then we can kind of break that down so that we have 2 triangles, and then we turn this into 30 degrees because we split up the 60, and then that would split the base to 1, and then we can use Pythagorean theorem to find that missing side length. And then if we have 2 45-degree angles in our triangle, and then this one would be a 90-degree, then we could just call each of the sides 1, and then we could solve for the long side, the hypotenuse, using Pythagorean theorem again. And so with these triangles drawn, we can find all of our trig function values for these 3 angles that we use so often. So let's just take a look at one of them. So let's say we are interested in 60 degrees, which is in radians, it's pi over 3. So we would say, okay, sine, which is opposite over hypotenuse. So if we're at 60 degrees here, then sine is opposite over hypotenuse. So that's where we would get square root 3 over 2. And then cosine of that angle would be adjacent over hypotenuse, so that's why that's 1/2. And we could do that for all of the following trig functions, and we could do that for all of the remaining angles that we have here. And then just a note, 30 degrees is equal to pi over 6 in radians, 45 degrees is equal to pi over 4 in radians, and then like we just said, 60 degrees is pi over 3. And so our trig functions actually have cofunctions. And these are the 3 cofunctions. So for sine, the cofunction is cosine, you can tell by the name. Tangent, the cofunction is cotangent, and then secant, the cofunction is cosecant. And so what happens with the cofunctions is that they have, if you take complementary angles, so that's angles that add up to 90 degrees, then your function values are going to be equal if you plug in the complementary angles. So let me rephrase that for you. If we have, let's say, angle A over here, okay, so angle A and angle B, those are complementary. They're going to have to add up to 90 degrees. So complementary adds up to 90 degrees. And that's because this triangle already has a 90-degree angle here. So the missing angles have to total the other 90 to make up the triangles to 180 degrees. And so what you do with cofunctions is with these complementary angles, so sine of one of the angles would be cosine of the complementary angle, and same thing for tangent and cotangent, secant and cosecant. And so here's sort of just a way to look at it. If we know that the angles have to add up to 90, then if you know angle, let's say A, then to find the complementary angle, we called this angle B a moment ago, you would just say 90 degrees minus A. And if you're in radian measures, then you can do pi over 2, because pi over 2 is the radian measure for 90 degrees. So you would just do 90 degrees or pi over 2 minus the initial angle. And you would do this for all of your functions. So let's try to write some of these functions in terms of their cofunction. So let's start with cosine. Cosine's cofunction is sine. And so this angle is given in degrees, and then the symbol right here is minutes, so degrees and minutes. And so we know that the angles have to be complementary, they have to add up to 90. So we know that this should be in terms of sine, and that the total angles should add up to 90. So to find the missing angle, we just say 90 minus the angle we have to start with. And so if we subtract that, we would end up with 37 degrees 44 minutes. And so if you want to check, 37 degrees 44 minutes plus the 52 degrees 16 minutes would add up to 90. So cosine of 52 degrees essentially is sine of 37 or 38 degrees if we round. And then how about for tangent? So tangent of pi over 6, same thing, the angles have to add up to 90 degrees, or in this case we're doing radians, so they have to add up to pi over 2. So if we're working with its cofunction, which is cotangent, we have to subtract to find the missing angle. So we're going to say pi over 2 minus our given angle of pi over 6, and then that would leave us with pi over 3. So tangent of pi over 6 is equal to cotangent of pi over 3. And then last one here, secant of angle 1, its cofunction is cosecant, and so this is radians. So even though you don't see pi, a lot of times you'll see pi if it's in radians, but this is still in terms of radians. Pretty much unless you see a degree symbol, unless there's a degree symbol right here, then you have to assume it's radians. And so we're using our pi over 2 for our complementary angle. So secant's cofunction is cosecant, and then we want the complementary angle, so we say pi over 2 minus 1. Alright, so now let's talk about some reference angles. So a reference angle is basically a positive acute angle and made with the x-axis. So that pretty much puts you in quadrant 1. And it's a angle that you can use to find your trig function values, even if your other angle, your original angle, doesn't actually exist in quadrant 1. So here's what I'm talking about. If you have your angle that, like, let's say it terminates in quadrant 3. Then you would go sweep around until your terminal side is in quadrant 3. But what you can do is you can find a reference angle, which would be a positive acute angle, and work with that, and it's actually the equivalent of what that angle would have been if it were to be in quadrant 1. And so that's the angle that you use to find your trig function values. So basically what you have to keep track of here is whether or not your trig function will be positive or negative. So there's 4 possibilities. If your angle is already in quadrant 1, then you don't need a reference angle because you are already working with the positive acute angle. So since we're going to call the reference angle theta prime, then theta is just equal to theta prime. If your angle ends in quadrant 2, then the reference angle would be made with the negative x-axis, and so you could find that value of theta prime by saying 180 degrees, which is this straight line angle, minus theta. If you're in quadrant 3, then your reference angle, this acute angle, would be found by taking that angle, which is actually a little bit more than 180 degrees, and subtracting 180 from it, and then that would give you this acute angle, your reference angle. And then last, if your angle's in quadrant 4, then you're almost all the way around to 360 degrees, so you would find this reference angle by saying 360 degrees minus theta. So let's try an example. We're going to find the reference angle for each of these angles. So starting with 218 degrees, first we need to recognize what quadrant that's in. And so that would put us in quadrant 3. So in quadrant 3, the acute angle would be between 180 degrees and our actual angle. So we could say our angle minus 180. So that's what we had in the previous slide. We said theta minus 180. And so our angle minus 180, and so our reference angle here would be 38 degrees. And how about for 1387 degrees? So first of all, we know that's more than one rotation around the circle, because that's 360 degrees would be one rotation. So it's actually 3 full rotations. So if you didn't recognize how many times around this circle we would go, you could just start subtracting 360 until you get to something less than 360. So you could say minus 360, minus 360, minus 360, and then you would get to 307. And once you get to a number less than 360, then you could stop subtracting multiples of 360. And so this is where you're at. You're at 307 degrees, which would put you in quadrant 4. And then the reference angle would be made with the positive x-axis, which is at 360 degrees. And so how you would find that is you would take 360 minus your angle theta, and that would give you your reference angle. On this one, it's 53 degrees. And then how about in radians? So for 5 pi over 6. So 5 pi over 6 is going to put us in quadrant 2. And you can tell because 180 degrees is pi, so pi would be this negative x-axis, and that's like 6 pi over 6 would give you pi. And so to get our reference angle here, which is going to be pi over 6, we would just end up subtracting our angle from pi. So if this was in degrees, this would have been 180 minus theta, but it's pi minus 5 pi over 6, and that gives us our reference angle of pi over 6. Okay, so now that we know how to find reference angles, let's find the values of the trig function for our given angle. So starting with an angle that's not one of our acute positive angles, so this one's 210, the reference angle for that, so first of all think about where that lands. 210 would put us in quadrant 3, and so we would say 210 minus 180, our reference angle would be 30 degrees. So we're basically thinking about, okay, 30 degrees, that's how we would form our triangle in quadrant 1, and then we could have the sides of our triangle, and then we could find our 6 trig function values. So in quadrant 1, for 30 degrees, this would be 1 for the opposite side, it would be square root 3 for the adjacent side, and it would be 2 for the hypotenuse. And then if we do that, we would actually not have the correct positive or negatives on our function, so we do have to consider the fact that in quadrant 3, both x and y are negative. So we could find our trig function values, but then just refer back to the fact that we are in quadrant 3, so x and y are both negative, and so all of our trig functions will be affected by that. And so we'll have sine of 210 is the same as sine of 30 degrees, however it's just negative, so it'd be negative of sine of 30 degrees, so negative 1/2, and similar results for the remaining trig functions. So this is just some guidelines for finding your trig function values. So first of all, if your angle is more than 360 degrees, then what you want to do is find a coterminal angle, and this is similar to one of the examples we just did. by subtracting multiples of 360 until you get to an angle between 0 and 360. Then after you're within that 0 to 360 range, then you can find your reference angle, and then after that, then you can find your trig function values using the reference angle. You just have to then keep in mind the positive and negatives on your trig function values, because if you're using a reference angle, you have to just consider should your x and y values be positive or negative based on the quadrant your angle actually terminates in. So let's just try a couple of examples. So cosine of negative 240 degrees. Notice that this is not within 0 to 360. So first we have to find a coterminal angle. And so for this case, you would just start adding multiples of 360. And if you just add 360 one time, we'll get within our 0 to 360 range. And so our coterminal angle would be 120 degrees. So visually, this is where we're at. If we had negative 240, it's the equivalent of positive 120 degrees. And then we want to next find a reference angle that makes this an acute angle, acute positive angle. And so that reference angle is going to be 60 degrees, because what we would need is 180 minus our angle, in this case our coterminal angle, so 180 minus 120. So our reference angle is 60 degrees, and then we can use all of our trig function values from 60 degrees, and then just keeping in mind that in quadrant 2, which is where this angle lands, x values are negative in this quadrant and y values are positive. We are looking at cosine, so cosine would be negative since it's involving x. So then we know cosine of negative 240 is actually the negative value of cosine of 60 degrees. So it would, instead of just 1/2, it would be negative 1/2. And then similar reasoning we could do for tangent of 675 degrees. We could start subtracting multiples of 360 until we get to 315 degrees, and that would put us in quadrant 4. And in quadrant 4, x is positive but y is negative. And so if we use our reference angle here, this reference angle would be found by doing 360 minus our angle of 315, and so we would get 45 degrees, and tangent of 45 degrees would give us 1, but because we have a negative y, we would want negative tangent of 45 degrees, so our final answer would be negative 1. So now what we're going to do is we're going to be finding the angle given the function value. So we're going to find the acute angle that satisfies the following equations. So we know that cosine theta is equal to 1/2, and we want to know, well, what is theta? Okay, so if we kind of work backwards here, thinking about our triangles, we have seen a cosine value of 1/2 before, and it came from the 30, 60, 90 degree triangle. And so this is our notation for inverse function. So this says cosine inverse of 1/2. So it's basically saying cosine inverse of both sides of this equation. And so you take cosine inverse of the output, and then what happens on the left side is you kind of like undo the cosine here, so you end up with theta is equal to this value. So cosine inverse gives you the angle, so theta equals cosine inverse of 1/2. So looking back at our triangle here, well, what angle has a cosine value of 1/2, and cosine is adjacent over hypotenuse? So if we pick 60 degrees, the adjacent side is 1 and the hypotenuse is 2, so cosine of 60 would be 1/2. So therefore cosine inverse of 1/2 is 60, or the angle theta is 60 degrees. For the next one, tangent theta equals to 1, we'll think about, we've seen that in this 45, 45, 90 degree triangle. And so tangent inverse of both sides would give you your angle. So tangent inverse on the left side of this equation, and then tangent inverse on the right side. Then the tangent inverse undoes tangent, and you're left with theta, the angle. So the angle we're looking for is tangent inverse of 1, and you're basically asking what angle has a tangent value equal to 1. And that angle is 45 degrees, because tangent is opposite over adjacent, and that would be 1/1 at a 45 degree angle. So the missing angle, or tangent inverse, of 1 is 45 degrees. How about this one? So we're going to find all values of our angle theta between 0 and 360, where cosine of that angle is negative square root 2 over 2. So first let's consider the quadrants that we're in. If cosine is negative, then we're either in quadrants 2 or 3. Okay, so that's going to help us narrow down our results. And so we're somewhere in quadrant 2 or in quadrant 3, and it could be both since we're looking for any values of theta that give us this cosine value. Okay, so if we just consider the positive, cosine theta equal to positive square root 2 over 2, well, that occurs in quadrant 1. If we kind of think of our reference angles, that occurs at 45 degrees in quadrant 1. So at 45 degrees, cosine is equal to square root 2 over 2. And going back to our triangles that we drew, you can come up with that, or that table that we had earlier, with all of the trig function values for 30 degrees, 45 degrees, and 60 degrees. And so if we want the angle, we say cosine inverse equals the angle. So cosine inverse of square root 2 over 2, and that would be from a 45 degree triangle here. So our reference angle is 45 degrees. And then remember, we are talking about quadrants 3 and 2 because cosine is negative. And so we do have two answers here. And in quadrant 2, we're using 180 minus 45 because we're going to go in this direction and get that missing angle. And so that would give us 135 degrees. And then in quadrant 3, we're going to say 180 plus the 45 to give us this angle, so 225 degrees. And so we could use the calculator. We could say cosine inverse of square root 2 over 2, negative square root 2 over 2. But just be careful with the calculator. It will only give you one answer. So you do want to do some analysis ahead of time and say, which quadrants could my angles be in? Is there more than one answer? And so the calculator would only give one answer, and then you'd have to recall, like, okay, there's also an angle in quadrant 3 in this case, and so you would say 180 plus for your reference angle to get that other missing answer. All right, let's do this last one. So the last thing we're going to do here is we're going to solve some right triangles given information about sides or angles. So we're going to solve the right triangle ABC over here, given one of the angles in the triangle, angle A, and one of the side lengths, angle C. Okay, so here's the picture of it, and then let's think about what we know. If it's a right triangle, we know that one of the angles is 90 degrees, and that the total angles in any triangle is always 180 degrees. So if it's a right triangle, then one of the 90 degree angle, we can kind of just ignore that and know that the other angle has to add up to 90. The other two angles have to add up to 90. So this missing angle over here, angle B, it has to add up to 90 with the angle we know. So we'll start there. So angle B is just 90 minus the angle we know. So if we subtract that, and we just convert 90 degrees to 89 degrees in 60 minutes so that we could do this subtraction. It's just like borrowing a degree and turning it into 60 minutes, since 1 degree is equal to 60 minutes. And so if we do that subtraction, we get that our missing angle is 55 degrees 30 minutes. Okay, so we have all three angles now in the triangle. So angle B, we now know. We knew angle A to start with, and angle C is 90 degrees. Okay, so we know three angles, and to solve a triangle, you have to know all three angles and all three sides. And so we have one side, we need two more sides. Okay, so we're going to use the fact that we know one of the angles and one of the sides, and we'll solve for the other sides. Okay, so sine of one of our angles. Okay, so notice what we're working with. So sine, we know, is opposite over hypotenuse. So if we are focused over here on angle A, then opposite would be little a, so this would be the opposite of angle A. And then the hypotenuse would be the long side here, length C. Okay, so opposite over hypotenuse, and so we can plug in what we know. We know angle A, and we know the hypotenuse. And so notice what you have here after you plug in the information you know. You have an equation with only one unknown value. So we can solve this. So this equation, if we multiply both sides by the denominator, it's going to give us our missing side. So we just say 12.7 times sine, and that's about 7.19 inches. And there, now we have 2 out of our 3 side lengths. And so we can use similar reasoning, but we'll use cosine this time to find the last side length. So if we use cosine, so cosine of our given angle, cosine of A, cosine is adjacent over hypotenuse. And so for our image here, the adjacent to angle A would be over here, side B. So adjacent would be B over the hypotenuse, which is 12.7. Okay, so we fill in our values. We know our angle A, we know our hypotenuse, and then we just solve this equation for the unknown value of B. And so B is 12.7 times our cosine of our angle, which is about 12.5 inches. So we have solved this triangle. So when you solve a triangle, you have to find all 3 side lengths and all 3 angle measures. Alright, for this one, we're going to still solve a triangle, a right triangle, but you're only given 2 sides. We do know that there's a 190-degree angle, but we're not given any other angle. So this one, the approach is a little different, but overall we're finding the same things, all 3 side lengths, all 3 angles. So we have our sketch here, and let's start with sine. So sine, we know what that is by definition. Sine of our angles is opposite over hypotenuse. And so if we say sine of, let's pick angle A, which we don't know this angle, but sine would be this opposite side. So it would be side A over the hypotenuse, which is side C. So we're basically using the only information we know, the 2 side lengths. So we need to find this angle theta. And what we can do is we can use inverse of our sine function. So if we actually use a calculator, we would say sine inverse of both sides of this function, and on the left side the sine inverse would undo sine and we would get that angle A, and so on the right side we would have sine inverse of that value, and then that's where we would just plug this into the calculator. So sine inverse of 29.43 divided by 53.58, and in the calculator that would give us that A is approximately 33.32 degrees. So we have one of our angles, and we know that if this angle is about 33 degrees, we just subtract that from 90 to get the other angle over here, the missing angle B. And so 90 minus 33.32 degrees, we then have our second angle that we were missing. So we have all 3 angles now. One of them is 90, and then we found angles A and B. Okay, so not too bad. We found the 2 angles. We had to use sine inverse to find them. And then last, we just need to find our missing side. We have 2 out of our 3 sides. So for that one, we're just going to use our Pythagorean theorem. Pythagorean theorem just says that 2 sides, so we'll say side A and B over here, 2 legs of the triangle, when you square them and add them, it equals the hypotenuse squared. So leg A squared plus leg B squared equals the hypotenuse squared. And so we know the hypotenuse, and we know one of the sides, so we're actually just going to solve this equation for the missing side. So if we just subtract the missing side from both sides of this equation, then we have this here, or we subtract the known side from both sides of this equation. So then we can plug in our values, and we just start solving and simplifying, and so we get B squared is equal to this quantity, and then just use a calculator to simplify that, and you would get that the missing side is about 44.77 centimeters. And our units of centimeters is just because that's what was given for these lengths previously. Alright, so we did quite a bit here with our trig functions and lots of uses for them. So thank you so much for watching.